This will be primarily focusing on our toolkit, very little AutoCAD electrical specific pieces in here. If you're looking for AutoCAD electrical things, you'll want to look for other topics, other videos that are going on. So we're going to be focusing just on our toolkit in this relatively short time. Spatial Business Systems has a variety of products for the substation design industry. We have two products, physical for Inventor and physical for AutoCAD. We won't be talking about those today at all. Today we're going to be working with protection and control. P&C is a piece here. The advantages of our toolkit are that all representations are linked, edits happen automatically. Our toolkit is actually focused specifically on the electrical design pieces. A lot of this functionality is based on AutoCAD electrical, so if you're not familiar, I would advise getting some of that as well. Automated reports, bill of material pieces, automating the tools that are very redundant, very time-consuming, not using specialized tools. We also include real-time error checking and audit reports, both from AutoCAD Electrical and our toolkit. We provide symbol libraries, part catalogs, and other reference files specifically for the utility industry to help get you started and help working. And we have several brownfield workflows. I'll be showing one of those today to easily add intelligence to your AutoCAD and even raster drawings that you're working with. The integration of our tools starts with AutoCAD, and this is really important because AutoCAD is the #1 drafting software in the world. Just about every company has a copy or two of AutoCAD running around. It provides the graphic engine, and it's a very general tool, right? It can do just about anything. I think of it more as like the drafting board for those old enough to remember those things. But in an electronic version. Very flexible, can do everything, but not as much automation as could be there. On top of that is AutoCAD Electrical. So this tool takes that AutoCAD platform and it's now focusing it down to schematic designs of any type, right? We could do P&ID drawings and hydraulic drawings, logic diagrams, anything that's based on a schematic. AutoCAD Electrical is a great tool for and provides the backbone for a lot of our functionality because we're creating schematic designs. And on top of that is our SDS-P&C Toolkit that provides tools specific for the substation design industry, which is pretty unique in the world of schematic design. It has some its own various rules and methods and workflows and so on. So that's where our tool resides, is that specialized version for protection and control industry. The key point to this is that we're built, our core foundations are all coming back to AutoCAD, which means if we are storing all of our information in a DWG file, we are completely 100% compatible with any software that'll open a DWG file. We use those core entities and provide our automation with it. That you can see in this next slide, where we start with the 3 core concepts I like to think of our design process. Search paths, right? So where you store your symbol libraries, your reference files, and so on. You can set those up to vary between customers, to vary between projects that you're working on. But again, very generic to AutoCAD, layers, and so on. The layers we use to define certain visibility states. You'll see that today with the job work order tool. Wires in AutoCAD Electrical are specific layers that are defined to be wires, right? Just some example. But again, you can see very generic to AutoCAD. And finally, the most important one we work with is blocks with attributes. If you haven't used those before, that is the core basis of how the software is storing and maintaining the data in the drawings, blocks with attributes. And again, a very generic AutoCAD tool that's been around forever. So you don't have to worry about being backwards compatible. You don't have to worry about taking your drawings and share them with non-SDS-P&C Toolkit or non-AutoCAD Electrical people. We're still just blocks and attributes in the software. So that was my very brief overview of the software itself. And now I'm just going to get started and jump right into the presentation. So you'll notice that we have 3 extra tools across the top: SDS Projects, Schematic, and Panel. We do have some tools built in from AutoCAD as well into our toolbars, just because they are core functionality. I'll be concentrating a lot today, though, as I mentioned, just on our P&C Toolkit in order to fit it into our time zone. I'm going to start with some basic, kind of simple tools where we build on top of the functionality that you might already be familiar with. For example, I'm going to start by moving to our schematic tab. You can see I have a typical 3-line drawing open, and I want to pick on the Show Wires tool. Now, Show Wires is available in AutoCAD as well, or AutoCAD Electrical, but this has an enhanced flavor with it. Notice it's showing you all 5 wire layers, so it's already telling you how many wire layers are in your drawing. And now I can start cycling through those just by hitting any key. And you can see now I'm showing just the smart bus layers. Next is external wires. Notice that down here, layer 2 of 5 is these wires. And internal wires, regular wires, and so on as I go through the project. So pretty cool functionality to be able to see all the wires in the drawing. And you can even see some that should be set up as wires, but are not. So it's a great auditing, checking tool as well. We also have a tool that allows you to check or follow the phasing in your drawing. So if I go to that same flyout and pick Show Phase, I can now check or select each one of these wires that are in my phasing, and notice how they're showing up as different colors, and they're tracing the phase all the way from my CT up here down to the protection relay down in this area, passing through various terminals, test switches, and so on. And it even highlights the grounding area here. So again, you can be checking if there's more than 1 or 2 multiple tools that are in here. So again, enhancements to the tools that take it beyond what you just might use in normal AutoCAD. Another tool I'll show, again, kind of a simple one, is Show Signals. This one comes in, and in a drawing where you have source and destination arrows moving around the drawing, you can select the drawing or parts of the drawing and see visually where those signals are going. If I zoom in on one of these spots up in here, you can see there's a source marker at the end of this wire, and there's a destination here. So the wires are ending here and then continuing on up into the next part of the drawing. One of the things you might notice with our software and the tool is that I can zoom and pan, and the highlights or the temporary graphics that we install are still visible to you until you start a different command or you hit the escape key. Okay. One of the other tools that I'd like to show, this one's really one of our favorites, especially as a checker or drafter, if you're working with the drawings at all, is our Rollover tool. So if we go up here to our little paintbrush or roller, and I pick on that, that starts our Rollover tool. And what it means is I can go over any intelligent AutoCAD electrical entity, actually SDS-P&C Toolkit entity, and it'll list for me information about that entity. So if here I am over a component, so it's listing the tag, location, item. If I scroll over a wire, let's see, oops, I ended my command. Let me restart that. If I go over a wire, it shows me the wire numbers, what layer it's on, and so on. And if I go over a terminal, it gives me that terminal information as well as the internal, external references. This is one of my favorite tools as I'm setting up wiring diagrams. I can easily scroll over the various entities and see what's going on with those tools. Again, great tools, kind of simple, but really they help things out so much. Okay, next up, I want to start diving into some specific tools for the SDS Toolkit, some of our brand new, kind of more powerful tools. One I'm going to start with is the data editor tool. So I'm going to open a different drawing. This one I'm going to spend in a couple of tools I'm going to show you on here, just because it's kind of a simple drawing. It's easy to visualize what's going on. Just kind of remember that it's a simple drawing only because it makes it easier to visualize, but this could be, a huge drawing. These tools work project-wide as well. The data editor tool is found on our project tab. You'll see it on the left-hand side. And this tool is really set up to help you create standards in your drawings and use those standards over and over again easily. What we allow you to do, or enable you to do, is to set up wildcards in your drawing. And you'll see those in here. That's our term for this, wildcards. $V3, $B2, V1, V4, and so on. And what this does is now I can go into my data editor tool, brings up this dialog, and I can search for those wildcards in the drawing or in the project. Now I'm just going to stick with the active drawing only, again, to keep it a little simpler, and pick update search, and it goes through the entire drawing to find out all of those values. And all I need to do now is start telling it what values I want to be in place of those. This becomes, it's kind of like the search or find and replace tool in Word, but much more powerful, right? We have a lot more selections specific for our projects that we're working in. We can look for specific installation location codes and place it in. And this is where it can become really valuable, right? For example, this panel might be P201, right? Just one of my favorite ones. And maybe this, some companies use the installation for the KV rating of the device. Now look, I'm changing up to 49 and 45 different pieces all at once. Even here, I'll pass through these and put in some values just so you can see it pretty quickly and easily. Those of you who've seen some of my presentations before have seen these same kind of pieces or presentations. When I pick process drawing, it now lists for me all of the pieces that it's looking for and finding in the drawing. So if you find something that you don't want changed, this is your chance to be able to select that. Just deselect the button here, and now you see that one won't be replaced. I'll leave that off just so we can see that update. And then from here, just pick OK and update. It'll ask you if you want to save those items in a search. Maybe you want to use it on a different drawing. And I'll pick yes, and it's processed 105 of these variables. Notice these are all marked as 0. This one has 1 because we missed one of them. And if we look at the drawing file, here are all those values that were in, and here's the one V2 that we ignored from our listing. So imagine doing that manually as you brought in a standard and went through and had to manually edit 104 different pieces on each one of those components. You can see how this could easily take, and this comes from one of our customers, actually the one that requested this tool, took their time for creating a new substation based on standards from 3 weeks to 3 days. So pretty phenomenal savings with this tool. Also, you can use it as a simple text string search that, again, gets much more powerful. For example, if I wanted to change a couple of these back, I could just put into here 300 as the search value and tell it I wanted to create it to V3, right? Basically put that wildcard back that I had in there, and I'll just pick the 100 one as well. We don't need to repeat it for every V1 $, right? So now I can do the search again. It looks through the drawing and found 3 of each of those. And again, I can process the drawing or the project to make sure everything is updated and complete. Right, so now you can see that's how you could even create this. And the real power comes in because there also is a feature to be able to import from a spreadsheet, so you could set up these codes project-wide, multiple codes across multiple drawings, get everything updated in your project all at one time. Very powerful tools that we have to work with. Okay, so that's our data editor tool. Next, I want to show you the job work order tool and what it's designed for. So basically, what we found with our customers is that when they had a work order, say a breaker replacement, or what I'm going to do is replace this circuit in here with something else, they ended up creating multiple drawings that would get released out into the field. And then at some point, all of those drawings would come back and they'd have to correlate 3 or 4 different drawing files all back together into one. So our premise is that we can help with all of that process by basically making sure we're working with just one drawing file and to give you the tools to help mark up and work with those drawings. So here's the scenario we're going to do. I'm going to replace this circuit with a different one. So we'll go through and do that. I'm going to pick the job work order tool, and our dialog box will appear here in just a second. Updating the counts in the project right now. You can see we have a little status bar down here in the corner. Updating counts is really where we're building up this piece. Now I don't have any current job work orders, so I'm going to create one in my drawing. And as soon as I hit tab or enter, it takes me into this mark entities tool. So I want to remove these entities. I'm going to skip this because I did a rebuild earlier. And I want to remove these entities from my drawing. Now remember, I'm still working in the one drawing, and you can see what we have done is move those entities to a different layer. That's really how we're doing and marking these changes to change the display of them. So now I can hit done and back, and it takes me back into my main dialog. From here, generally the next step to that might be to put a cloud around this and maybe hatching to show that those entities are being removed. So we have tools that automatically enable that as well for that job work order. I want to pick all of the entities on this drawing that are marked as remove. I'm going to add revision clouds and even add hatches for it. And I'll just pick the active drawing option. The software now determines what entities are being selected as part of the selection set, and it's going to place that cloud around the entities automatically. Remember, this would do it drawing wide. I only have this one selection, but you can see how it's doing it all in here. Okay, so we're done with that portion. Now, at this point, right, I could exit this tool. In fact, I will. And you could send this drawing out to the shop, right? Just send it off and be printed now. You could save it in this state. If you have Vault, you could check it in as the demo drawing kind of piece. Okay, so now I want to take that same drawing, right, the same one we're in, and I want to put in my new circuitry with that. Well, what I can do is just pick those remove entities and hide all of those pieces that are on that layer. Right, so it's still in the drawing, but now it's on a frozen layer in the background. So now I can add my new information that I want to place into the drawing. So I'm going to go to my schematic tab, pick insert circuit, and I have a circuit created just for this. Oh, I thought I had one. So I don't, so I'm going to copy a different piece into there, right? So I'm just going to copy this circuit and place it over to that line. Oops. Let me grab this guy here. Base point, I'm going to grab the end point of here. Select these entities. And now I want to paste them back in. I'm going to keep any source arrows that I have with it and place it onto my run. Oh, I actually placed it wrong. Let's just say that that is all correct. I've added my new stuff into here. Now I'm going to go back to my job work order tool, job work order display, pick that work order, and now I want to mark these so people know this is the newly added pieces into the piece. So I'm going to select add, mark those entities, And now I want to do the same thing. Maybe I want to put a cloud around those entities, but in this case, I don't select that, go to the add, but I don't want to add hatches around it, right? We want people to be able to see the information that's in the background there. So now I'll just hit the same clouding tool and it places the cloud around my entities. Right, so there's how you can set the workflow. Now I can exit the drawing, send that out, save it, check it in, do that kind of thing. Remember, we're still all in the same drawing. All of the entities are still there. Now, let's say we're finished with all of this work, right? So it's coming back, it's all as built. I'm still in the same drawing. Now I can go to this remove. I'm going to show that. We can see there's the green entities behind it. But now this is the as-built. We're done with this extra work. I can come into our tool, pick normalize, right? And I can, or the utilities piece, and I'm going to go to the remove piece and tell it that I want to erase all of those remove entities, right? We don't need them for historical pieces anymore. We just want to take them out of our drawing. So I'll pick on that one for the active drawing, and you'll see that all of the entities in the background have been removed. The hatching and the cloud is still available there. I also want to take the add entities, right, and put them back to their normal layers where they normally be placed in a component or in the drawing. We'll place those as well. You can see how the layers have now been changed back. And then my last step is simply to jump back, exit the tools, and erase the two cloud pieces we have, and we have our drawings ready to go. Okay, so pretty cool stuff that's going on with that. Now, the next tool that I want to show you is our Subproject tool. This is a relatively new tool that we've created in just for the 8.6 release, which is our latest one. So what I'm going to do with that, I'll leave this drawing open for now, it doesn't matter. I'm going to create a sub-project, a smaller set of the drawings that I want to work with, right? Many of your projects end up being 100 drawings, 300 drawings, however, and it's hard to manipulate and work with that many drawings all at one time. And also, you don't need them all. You only need the work of its various pieces. So that's where our sub-project tool comes in. We also go on the premise, once again, that we don't want to make copies of the drawings. So we're actually working in our sub-project on just a subset of the same drawings that are in the same project. So when I start the tool, we're going to create a sub-project in the same folder as our main project. But wait, there's more. This is not just a tool to select drawings. For example, I know one of the drawings I want to work with is drawing 14, so I can just pick that, add it to my sub-project drawing list. But here's the really cool part. Let's say I know that I want to work with a protection relay, and I'm going to replace that with a different one. And I happen to know the protection relay name. You can see I'm scrolling through all of the components in my project. It's an R1, right? That's its tag name. As soon as I select that component, the software finds all of the references for that component and lists all of those drawings here for you. So you can see I have 5 drawings here where R1 is referenced. Well, of course, if I remove it from one, I need to work with those others. So immediately, now I can just pick this, add this to my sub-project, and here are those now 6 drawings, the one I added manually, and those other 6 drawing pieces that are coming through. Very cool functionality, right? No longer do you have to try to manually search through finding all of the references. You don't have to worry about missing a drawing. They'll all be shown up here in this sub-project. When I create this sub-project, you'll notice that it's copying from the base folder, right? That's my current project. It's where it's copying them from. It's also placing the new subfolder into that same folder, or same sub-project into that same folder. And I'm just going to change this to webinar as my sub-project name. And notice we're enforcing the project name piece, because we have new functionality coming out that's also building on this tool of creating the subproject. And in order to do that, we need to know what the subproject is. And by having that just as a suffix, we can know what the subproject name is. So now it's taken those drawings, it is adding them to the project, it is updating the Scratch database that goes with that project and so on. And it's going to make that project the active project. And you can see there's my 6 drawings that are in there. And not only do the drawings come in, but also the subfolders that they were a part of. So you'll see the same drawings listed the same way in here. And all of the drawing and project properties are coming in as well. So if I look here, where normally if you would just create a standard piece, that information isn't coming in with it, but our tool brings all of that in, so you're working with basically the same entities all of the time. Very cool functionality, and again, they're part of the main project, so any changes I make to this drawing are being made in my main project. Again, we're working on the exact same drawings. Okay, cool new functionality with that. Next, I'm going to open up drawing 7, and I want to show a couple of neat things here, working with Brownfield tools and the cable fan-in, fan-out tool. So I'm sure I have some of you that are used to AutoCAD Electrical and are just curious about our tools. This is going to be another great example of how we build on AutoCAD Electrical to provide better, more focused functionality for utility design. What I'm going to do in this drawing, you'll notice that there's colored entities, right? Orange, red, and so on, that represent intelligent components. And then I have these entities down here that are simple lines and text. Typical Brownfield piece that might come in. You open up a legacy DWG file, and now I need to make modifications to it. Remembering that this is just core AutoCAD at its base, we can now do multiple things with this. First of all, I could just start redrawing this, adding in terminals, some great tools to be able to help us with that, but maybe I don't need to do all of that work. So what we're going to do is enter in some tie links for this tool. Now this is a terminal entity, and I want my connection direction for the wires. I love saying that, by the way, connection direction, for the wires to go up, and then I'm going to place my cable marker off to the left. Now, this would require multiple steps in AutoCAD. If I was doing some of those pieces, my first step is just to tell the software that there's actual intelligent entities there. So we're going to trick the software by putting in little markers that carry the important information that I'm looking for. Right? This is terminal 5 going to terminal 8, and they start at, I'm going to place these in as an array. So I'm just picking the location points where I want the array to start and end, like a typical array would work, and place them in. Notice it did all of the copying of the spacing for me, calculated how many. And what's neat is, remember earlier I said graphics don't matter. It's all about the blocks and the attributes. While this looks like just a simple little marker indication, and that's really all it is, I can edit this component by right-clicking normal functionality, and it will appear to the software, our SDS-P&C Toolkit, as a terminal, just as if I placed in a regular terminal. You can see the installation codes, pieces, properties, details, manufacturer code, all of that attribute information is stored on that marker. The software sees that as if it was an actual terminal in the drawing. This enables you to quickly add intelligence, the necessary intelligence to drawings. For example, you might have a vendor drawing that comes in. We don't really want to change anything on that drawing, but we want to attach a cable to it and have that show up that we're going to that drawing and this terminal and this component, placing in some quick markers in here, easy and fast. Now I want to put a cable in. This is one of those tools that doing this in AutoCAD Electrical required like 4 or 5 different steps. And it was really a pain. It was kind of confusing. We've simplified that down to one simple command process. Going to put in my cable name. It's going to be a source side of the cable. I have multiple selections for what it's going to look like. I'll stick with rectangle, and I'm going to place the marker position at the left. Now I'm coming in, it's highlighting all of the wire connection points for me. I'm going to window around these four for the wires that I want to connect, drag this up, and drag it over to the left where I want my cable marker. It's where I have room to place it in. It's placing the cable marker in. I'm going to do a quick catalog lookup and assign the bill of material information to it. And this is an important step, right? Adding that information in now tells me what the wire colors are that are available for that part number that I selected, right? So this is all part of the processing. I pick OK here, and the software completes the rest of this for me. You'll notice in here, we're placing in the source destination arrows. We're putting in the color for the cable markers based on the part number catalog information. The software drew the fan in line up to here and placed the cable marker in, doing that all automatically in one step, right? Pretty amazing stuff. But now it gets better. Now I'm going to take this to a different drawing. Remember how I added drawing 14 to that selection set in my project as just a manual drawing place I put in? Well, that drawing is a raster drawing that we just embedded the raster image into a DWG file, so we have a digital record of it. And now I need to go back and attach a cable to it, right? The other end of that cable that I just inserted on there. So I'm going to zoom in a little bit. And as we can see, it is truly just a raster drawing. So I'm working with an image. And now I'm going to place in tie links on this end and complete that cable insertion. So I go back to tie links. This time I put in an array because as a raster drawing, it is much more random on how it was drawn. And I want the connection direction to be to the right. And this time I picked component instead. It's not a terminal strip anymore. It's 52-B, starts with number 6, and I'll place those in. So I'm putting in my connection here. Maybe I might place it on the quadrant or close to the quadrant in the actual drawing, but I want you to see these markers. Now notice 8 is over here. I don't want to connect to that. I'm connecting to 9. So a quick command line prompt to change that to a 9. And now I can complete my 2 pieces in here. And now go back to the schematic. Now that I have my tie links in, my intelligent connection points, I can come back into the other end of my cable fan in. And instead of having to retype all of that information, I can click on the list button, search through my list, and there is cable 23, right? The one we just completed putting in. Here are the 5 terminals coming from TBH. Here's the cable codes. Remember I was saying how it automatically put in those source destination arrows. So it's picked all of that information for me. It automatically knows this is the destination side of it and just where I want the cable marker to be. And like before, just select those 4 terminals, position the wires where I want, and there is my completed cable marker. Once again, you can see it's automatically placing in source, or in this case, the destination markers. It's placing in, drew the wires that were coming out from the components, switched those automatically to the multi-wire layer and placed in my component. Quick, easy steps to drawing cables between components in our drawings. Now, I use tie links to draw the cables in, but really the tie links were just providing the connection points for the cable that we're working on. All right. Next, I want to show, I have only a couple more things, so our timing is working out pretty well. I'm going to move back to my main project, right, the overall one that I had in here. and I'm going to go to drawing number 11, wiring diagrams. I'm kind of saving this one for the end because I know it's one of the more popular tools when it's shown on how it saves the time and effort for people. As soon as this finishes loading in the component here, there we go, and I'm going to start with drawing number 11. All right, I'm going to my panel tab, and I'm going to add the annotations. Now, this is a typical wiring diagram. Some people call them point-to-point diagrams, but it's all the same kind of thing. We're showing a graphical representation of the components, and we want to show where those components are connected. It's really the wire from to report, but we're showing half of it in graphics and saying, here is the component physically, and where does it go to with an annotation, and then somewhere there would be the opposite. This dialog shows me all of the options I have for how I want to format, how I want to see those annotations showing up in the diagram. You can see there's just a lot of different ways you can make changes. One simple dialog for that. I'm going to get this started, and as it's processing, what's happening is the software is looking back at the schematic, finding the wire connection points for the component. So it's looking at a component on this wiring diagram, like R1, that protection relay, looking in the schematic information, finding the pin numbers on that component, and now we're tracing that to where the wire is connected to, the other end of that component. And now it's placing the annotations in on the drawing for us. You can see it started pretty quickly here. I had it not processing the wire connections because we haven't changed anything for this particular setup in here. And this is running slower than normal. I'm sure it's that processing with the go-to meeting pieces in here. But you can see these annotations coming in. Not only are we placing the values in, but we're also drawing short line segments out to the components. Giving this just a few more minutes. And even as slow as this seems to be taking right now, it's still very quick, right? If you had to enter this stuff in manually to do it, and there we finally completed, it's really slowing down because of the different views and the GoToMeeting stuff going on. Okay, so we can see here how this annotation works. It's actually placing this in with this little wire. If we look at these component pieces, we can see the various connections and stuff going on. For example, and I want to show another couple of enhancements that we have as well. For this terminal, on terminal strip TA, terminal number 1, here's the wire number 4BC1. We have a cable with a red wire that's attaching from here going to TA20 on one side and TS12 on the other side. Okay, so let's take a look at that from the schematic. This gives me an opportunity to show another feature that we've built in. If I'm in the normal surf command, AutoCAD Electrical, I pick Surfer and I pick on that entity, it will provide for me a list of all of the TA1 terminals, both in the physical and in the electrical piece, right? So here are the physical ones. We can see that showing up with the hashtag or pound sign. And here are all of the schematic versions, right? The terminals that are actually on the schematic. Well, there's terminal 1. I could pick from that, right? So that's okay, but sometimes some of the devices get pretty detailed. It's hard to find them. What I can do is right-click just over that item number, right? The terminal number itself. And now when the dialog pops up, it shows me only that one. Much easier to find what I'm looking for. Now remember, we're TA1, TS112, and TA20 with that cable on the other side. If I hit my Surfer tool, now it takes me straight to that terminal, opens that drawing, zooms it into the screen for me. And if we look, there's TA1, there's cable 39 red. Here's the wire number, 4BC1 going to TA20 on one side and TS112 on the other, right? Just what we were looking for here, red cable, TS1, so on. Now, with all of these cables, I would like to carry those other places as well. So I'd like to fan those in. Great, similar to the cable fan in. They're kind of the same name, right? Cable fan in. But on the wiring diagram side, it does different things because we're not dealing with actual wires here. These are just the annotations. So we have two different modes that we can work with on this side, the auto mode and the manual mode. So manual would mean I would just pick the 4 wires, place, and I'd have to go through and manually pick them, manually locate where all of the components are. On some bigger terminal strips, that can end up taking quite a bit of time. So we have this interesting, cool tool, the cable fan in auto piece. You can see down here we have our progress bar tracking the information. So it's reading all of those places. It's trying to avoid any crossing lines that might take place. And there we go. We have all of our cables automatically entered. Notice this one's even telling you on this particular cable, we have 2 spare wires that we could do. This one is telling us that 53 is continued on this drawing under E1, which is right over in here where the other cable is ending up and so on. Right? Pretty cool stuff that's going on with that. We have this neat tool in here. Sometimes people like to see the wiring going from point to point, and other times you want to see a physical jumper drawn in instead. So if I pick on this jumper piece, it automatically draws in that physical jumper, right? Zooms out, places that in. And it's erased or hidden the annotation that was there because it's not needed because of the physical jumper piece that's going on in there instead. Instead of just single entities, I can now this window the area that I want to put the jumpers in, and it's going to do the same thing. It's going to find matching components, put the jumper in, remove the annotation that's there, and also make sure that when they're placing them in, it avoids doing any intersections, right, or overlapping of them of the wires. So when you see these pop in here in just a second, and it's also avoiding any jumpers that would cross over here that aren't orthogonal, right? Because I do have some jumpers listed that should go to B4. B4 is across here, so the software ignores them. You have to put them in manually. These are also dynamic blocks, so I can easily make changes to these using either the AutoCAD tool. So for example, this would be a lot cleaner if I would just move these around like this, right? So now it's not passing through both of them. Looks a lot better. So with that functionality, you can easily clean up and work with your drawings that are happening in there. Okay, I have one more tool that I want to show. This one's our cable schedule, cable lengths tool. What I'm doing here is going to these 2 drawings. I'm going to open them both. I'll start with the schematic version, and I'm going to come back to this one in a minute. I want to open the layout piece first. So I'm going to, as soon as it gets my drawing back here, what I have here is a layout that came from somewhere, right? Somebody could have drawn it in AutoCAD, you could have drawn it in Inventor or P4A or anything else and converted it to a DWG file to scale, right? And it's showing the layout of a yard. You can also do from Inventor, you can put in the work points and have that exported out for use in our tool as well, right? So more 3D accurate. With this, you can do this in multiple ways. What we're doing is we're putting in work points. We're calling them that, but they're really like waypoints. Where do cables start from? How do they get routed through the yard back to between components, back to different panels? As an example, we start with this one, that this is the location, it's XF41, and we're telling it to enter this conduit path, right? C path is listed here. From there, C path goes over to the other end. You'll see CO2.A. .B is now entering a trench. From the trench, we can see they're connected up to here through these different points. Not really going to get into all the coding today. That would be another session. And from the trench, it's going through and calculating down where we're ending up. So in our example, we're going to end up at junction box 3, and you can see entering trench 1, which is up here at this point. The trench is now, the software is going to calculate the shortest path from XF41, that's where we're going to start from, into the conduit, enters the trench, goes back to the control house where the information's in. If we look at the schematic drawing, well, before I leave this drawing, I'm going to read those work points, right? I'm going to save those off into a file that the software will then process to give us the rest of our information. If I look at this drawing, this is the schematic that matches up with that. You'll see here I have this device XF41 transformer. Here's the terminal strip on that transformer, XF41, and these terminal numbers. We're going to focus on cable 156, just the pick one that's in here. And notice that cable ends up at junction box 3, pieces that are inside of there. That's all pretty critical to what we're doing and what we're working on. Okay, so that's the basis for the information. I'm going to run the cable schedule tool. I'm going to select the format. My pieces aren't in here. I might have to add those in a little bit. We'll see what happens. Let's see, fresh, and I'm going to process the information. I was doing some experimenting this morning before the webinar, and something must have gotten erased when I was going between the beta software and this one. No worries, we'll still be able to show all of the information here. While it's reading that data there, I'm just checking on some of the questions. For adding equipment into the schematic for the work order, does the clouding cascade into the wiring too? I think you saw that it was doing that stuff in there. So that was from Brian. So hopefully that answered your question. If not, come back and let me, re-enter it in the chat. Okay, so here is that report, right? We came back in here. Here's cable 156. You can see there is the parent, and I have the other child components that are going with it. This is one of the things I think is so neat about the software, how it tells me exactly where this information is. I'm going to change this report format. I like to see it in a slightly different order. So just to make the change, right, I'm going to do it pretty quickly here, just moving the location up a little bit and pick OK. Does show you how easy it is to create our different reports. Notice now this is coming in for each wire. Here's the wire number. It starts at XF41 component. That's the terminal strip. D, pin 307. Where does it go to? JB3. That's the junction box. The component is JT5, pin 42. Amazing information into there. But wait, we want to see more stuff than that. So I'm going to go to the report format. I did have this set up, so I apologize that I have to go back and do all of this stuff. I was hoping to save this time in the presentation. I'm just adding these fields in to do extra pieces in here. It must have lost my stuff. So I'm just adding these extra columns to our report display to show us the information from our wire for our cable schedule report, our distances, and so on. I'm going to add one more, and then I'll stop. Okay, now normally I'd have these all renamed for you as well, but we're going to skip past that part, right? So there's my report with those extra fields added in. I'm even going to make this make it a little wider so I can see the values. And now I'm going to go to our special command, user post, where now we have this cablecon.list file that we're adding in that gives us all of these options for how we want to manipulate the data. For example, the cable schedule path is going on here. This is one that I think is important. We're showing only the core conductor, right? Just the cable itself, basically the parent. We don't really need for this part to see all of the individual wire information. So I'm going to simplify the report down. Instead of 6 lines, we'll just see it as one cable 156. Down here, I also want to show my cable and trench pieces, right? Where the wires are going through, what the fill is coming in. Notice we have a calculated length that we can place in here as well. And you saw I was adding those extra fields. Here how they're all coming in, right? User 20, 19, 18, 17, and so on. Okay, so when I pick OK here, the first thing that it's going to show me or calculate is the trench runs, right? So it's reading from that wire work point list that we created, and seeing in the lower right corner, the cable routing progress. It's running an algorithm to find the shortest path from XF41 to the junction box, and it comes back with this report. Our duct report is saying which channels. Remember, we were going into conduit 1. There's cable 156, right? So it's going into conduit 2. And then from there, it's going to conduit 3, and then goes to conduit 1, and then off into the control house, right? And it's giving you which cables are in there, the diameters, the fill ratios, all depending on the information that you have entered into your drawing and the intelligence you add on those work points and so on. So that's the first step. Pretty cool piece. You can see where that part starts. When I close from here, because I had selected the duct report, it's still running those reports. And now it's coming down to this report. Now I'm going to make one change in here. Here it's listing all of the wire numbers that were on cable 156. We really don't need to see them for now, so I'm going to take out that wire number column. That gives us more room for our dialog, right? So now it's showing us the normal pin from 2 stuff we looked at before, and now we get the really cool information. Here's the distance it calculated, 164 feet. Then we had a 10% cushion factor that we placed in. I pointed that out. Well, 164 plus approximately 16.34 is 180.7, right? So that might be your actual number that you want to see and use. This is unit of measure. It's done in feet. Now these next columns are how that path is being calculated. It's starting from the location point, right? And here is just the paths themselves. Here it is with the starting and end point. So I start from XF41 into conduit 2, trench 3, trench 1, off into the junction box, right? And 15 was just something else. In fact, I think it's pretty much the same piece in there. It's showing me starting from here, conduit paths, that kind of thing.